So let me introduce the next speaker, Jimmy Lai. The title is Build a Searchable Knowledge Base. And Jimmy Lai is a Python fan, and his interested topics are natural language processing and machine learning. So let's give him a hand.
Hi, I'm Jimmy Lai, and I'm very glad to have a chance to deliver this topic, build a searchable knowledge base. And I'm a search software engineer in Yahoo. So this slide is available on SlideShare. You can just search my user ID, Jimmy_Lai. And okay, so let's start. So you may notice that the current modern search engine will not just return the web pages URLs. It will try to answer your question directly. For example, you search a restaurant name, it will try to give the information of that restaurant in the right-hand side of the page. So so this is actually using a knowledge base to try to answer users' question. And so today we are talking about how to construct a knowledge base and how to make it searchable. So so the outline we will introduce what is a knowledge base and also how to construct a knowledge base, and after that how do we make it searchable by some text search techniques. And then we will based on the searchable knowledge base to see what kind of application we can make. So Francis Bacon said knowledge is powerful. So it's important that if we can easily access the knowledge, we can learn more and it will benefit our life. But knowledge is boundless, is anywhere. So it will be difficult to browse if we don't have an efficient interface to search. So that's why we would need to have some search ability to browse the knowledge base, and it's very essential. And so a knowledge base is would have lots of knowledge which is connected together, and then we can based on this searchable knowledge base to do some more intelligent applications. So let's see some application of knowledge base. So there are some intelligent personal assist on the mobile phone, like Apple Siri or Google Now. So basically, they have a knowledge base at their backend, and you can try to ask some questions by specify a query or just provide your context information. They will try to answering your question by search their knowledge base. And also in the search engine, there are knowledge graph. When you search something, if the search engine think you are looking for some knowledge, it will just show the knowledge on the right-hand side of the page. So a knowledge base is important for building some kind of intelligent service. And so let's see how to construct a knowledge base. So first we have to find some data sources, and then we have to do some data aggregation to aggregate those data as entities. We may have to do some cleaning and do also some text processing. And after that, we would construct a structured data of knowledge entity, and each entity are connected to each other. And then we have to able to search the knowledge base. Search is really important because without searchability, we cannot find the knowledge easily, because there are lots of knowledge in the knowledge database. And then we can, after that, we can easily browse and navigate the knowledge base by the searchability and the go over the connections between entities. So let's start from Wikipedia. Wikipedia is a collaborative encyclopedia. There are over 30 million articles, over 200 more languages. So it looks like a good data source as a knowledge base. But actually, the Wikipedia data is in MediaWiki form, and so the format is semi-structured. It's not well-structured. So if you process the Wikipedia data directly, you may encounter some problems. We will not process the Wikipedia data dump directly. We will take advantage at another project. It's called DBpedia. So DBpedia is a structured data dump from Wikipedia. So some people try to structuralize the data from Wikipedia. So it would be a good data source for a knowledge base if we using the DBpedia data. Let's take a look at an example. This is the Titanic wiki page in DBpedia. So in DBpedia, for each entity, you can see they are structured data. So here are many properties for Titanic, and so different properties are some property values, or some of them are links to external page or to other entities. So this data is much more easier for our use. So let's start to construct the knowledge entity. Here, as an example, we will only include the identifier and abstract and the relations in a knowledge entity. So the identifier is basically the URL of the DBpedia, and the abstract is freeform text, and the relations are the relation to other entities. So we would construct a knowledge base full of this kind of knowledge entity. So what can Python do for us when we build in the knowledge base? So Python can do text data processing to process the text data and do aggregation, and then output the data as JSON format. And after that, we can also use Python for connecting the data flow between different systems. We will have some automation script for starting services and feed the data, and also implement our final search strategy with REST API by using Python Django. Okay, so we provide some example code. You can get it from my GitHub, and so in this repository, we use some Python packages, including Fabric, PySolar, and Django. So you have to install it before you start to run the code. And okay, so let's start to work on the construction of knowledge base. So the first step is data preparation. So you have to download the data dump from DBpedia. So you may download different data dumps. Each data dumps is some properties of the entity, and we would do the aggregation on them. And there are some different formats provided in the Wikipedia. And here we are using the n-tuple format, which is very straightforward. Each line is a tuple, and the fields in the tuple are separated by space. So we would use some simple Python script to do the text extraction to get the data field we need. So and before that, we may also want to do some filtering on the type of entity, because Wikipedia contains different variants of knowledge type. We may only want to focus on some type of them. In our example, we are focused on the location type. So by running this script, it will try to filter all those knowledge entity which belong to places, and then after that, continue to run those scripts. We can get those data files, including abstract relations, latitude and longitude, and redirects. Latitude and longitude is for those entities which are related to location. They provide the geolocation information in the data dump. So by getting this data, we can do geo search. And then the redirects are the alias or synonym in Wikipedia. So when you browse in the Wikipedia, when you type a short name of some entity or an alias of some entity, you will be redirected to another entity. Those keywords are the redirects, and we can use those redirect keywords as the synonym, and it will be improve the search experience a lot. So the aggregated data format is very simple JSON format. So this is entity which is like usemate, and we have latitude, longitude, and redirects. You can see the redirects is simply a string with lowercase y, and also have an abstract string, and have relations to other entities. So like usemate is a type of reservoir, and the location, its location is in California. So based on this entity, we already have a knowledge base, and contains lots of place knowledge entity, and then we would like to provide some search feature for this knowledge base, and we are going to use Solr as our search engine. Solr is a full text and real-time search engine, and it's based on Apache Lucene. So basically, Solr is very easy to use. It provides REST-like API. So, and in Python, there is a package called PySolr. We can use it for easily access to Solr. So you can just download the latest version of Solr and extract the directory under Solr in the repository, and then you can just run the fabric command I provided to start a Solr server, and after that you can see a web UI in your browser with this URL. You can do some monitoring and experimentation on the web UI. Okay, so we are ready to do the index for our knowledge database. So let's start to do the search. So let's start from the simple stream match. So in Solr, we have to define the field of an entity and define their types. Here, in order to do the string match, we define name as a string and apps also as a string, and after that we can run this command to feed the data. Those config files are already provided in the repository, so you can just run this command. After you generate the aggregated JSON file, run this command, it will feed the data to the Solr. And what it does is just it is feeding the name and abstract for each entity to the Solr search engine, and after that we can start to do the search. So here, if we search specify the we want to search on the field name, and the keyword is San Francisco, we can get the entity in from the Solr. And this URL is the REST API provided by Solr. So we can see it's very straightforward. We just specify our query condition in parameter queue. Okay, so let's do some more complex search. So we would like to search some synonym. So in order to do that, we have to prepare a synonym list, and we generate the synonym file list by using the data from Wikipedia redirect. So by running this command, we will generate the synonym file, and here in the Solr schema, we define a spatial field type, which will do the synonym filtering in index time and also query time, and also do the low-case filters. And so after running this script, it will feed the data to the Solr for indexing, and during the index time, all the entity name will be replaced as the synonym entity name. So let's see an example. So during the indexing times, so San Francisco will still be San Francisco, and but in query time, we in the synonym list we have lots of synonym for San Francisco. One of them is City by the Bay. So during the query time, the synonym filter will apply on the query, and it will translate City by the Bay to San Francisco. And after that, we can get the same San Francisco knowledge entity. So those are some other synonyms of San Francisco. By searching all of these query, we can get the same. And this is pretty useful for user to access the knowledge graph, because user may just type an alias of the entity. And beyond that, we would like to provide a much more powerful full text search. If user are searching by some more free-form text, then in order to do that, we copy the field in Solr config to text field, and then when we do the search on Solr, it will do the without specify any field, it will do the full text search. So let's see an example. So this is when we search Yosemite Valley, and we will get some entities which they contains this keyword in their abstract and or names. And then we would also like to provide geo search for our knowledge base. So what we have to do is to add another field in Solr config, and when we feed the data, we feed the location field, which is like this format, the latitude and longitude are separated by a comma, and after that we can just specify some condition on distance given a point. So in this example, we are querying given an example in San Francisco, and then we can get some entities which is within the distance of 20 kilometers. And we can see those entities are actually some locations in San Francisco. So let's put all of them together. So when user given a query, first we may search by the synonym match. If we can get an entity for user, then it's good. If not, we would do the full text search. And in the meanwhile, if user specify a location, we would also like to filter the result by the geo search. And we can implement this search strategy using Python as an API. We are using a Django view to do this. So in the view, we create two connections to Solr using PySolr, and those two are, one is for synonym search and another one is for full text search and geo search. So we just get the query from HTTP request, and after that we query the synonym and then query the full text search index, and then return the result as a JSON string. So this is an example. We query San Francisco and also specify a point in San Francisco, and then we can get the result like this. So so far we have already implemented a knowledge base with a searchable API, and we can search by either synonym, full text, and geo search. And after that, we can, based on this, to provide much more intelligent applications. And also those entities are connected by relations, so we can also let user browse our entities by go through those relations. So to do some further applications, for example, we can do a question answering system. So in order to really answer a question, we have to do more advanced query analysis to identify what user's intention is. For example, we have to identify the knowledge entity type they are looking for, and after that we can generate some search queries to our knowledge base, and then we can get some knowledge entity and return those to user to answer their question. So based on this, we can implement a knowledge answering system. So let's take a look at some example in real world. So basically, the modern search engine, they don't just provide the URLs of webs. They try to answer your question. For example, the left picture is from Google. When you input username, it will return the structured information for you. And the right-hand side is from Yahoo. It also returns some useful information for you. So in order to do that, we may have to aggregate more data sources to provide further information. For example, the phone number, the map, the flights, hotels, and etc. So for more data sources, we can look for open data or open APIs. Programmable web is a website aggregates lots of open API. You can find lots of data sources here. Okay, so time is running up, so the talk is probably stop here. And in the end, I would like to introduce my life in Yahoo. So basically, I have opportunities to do some, to build online services for billions of users, and also have opportunity to use some cloud infrastructure for big data mining, and also can have opportunity to do international teamwork and English communication. And also, I visit twice to Silicon Valley, so I really enjoy the life in Yahoo. And if you like to know more about it, you can send me your resume if you need a referral. Okay. So, any questions?
I think we have time for one question if there's any. Any questions?
Oh, okay.
You just mentioned the Synonym text file in your slides.
Yes.
Can we append the new entities, Synonym entities, in real time, or we have to reload the solver?
I don't know the exact answer. So so my use case, I only reload the Solr. Oh, sorry. Okay, so I'm not that familiar with Solr, so I'm not sure whether it can be done in real time. Yeah.
Okay, let's thank the speaker once again.
Thank you.